We have heard a lot about LUMI in various presentations, and I'm very happy for that, of course, from users, various users here, from companies and other users that have presented, talked about LUMI in their presentation. So it could be time to tell a bit what it is in more detail. So thank you for giving me the opportunity to tell a bit about LUMI. So my name is Per Öster, and I'm Director of Advanced Computing Facility at CSC, which is the unit that deals with both our national, where we operate, develop, and support our national and international computing platforms at CSC in Finland. So in addition to LUMI, we have also a national computing facility for Finnish research and university research and research institutes and industry, of course, also. But LUMI. So this is something that started way back in 2018, really, when it came out a call from the formed organization EuroHPC joint undertaking to start a journey with large HPC, European HPC systems. And there was something called pre-exascale systems that were supposed to be a step towards the exascale. And we landed, as you will see, somewhere above a third of an exascale system. But to tell you something about LUMI, and I hope this slides comes through here, it's a bit of difficult light in the hall here, but up to the left corner you see the actual facility where LUMI is located. It is an old paper factory in the middle of Finland, in Kajaani. It's almost 600 kilometers north of Helsinki. We moved there with our national data center in 2012 already. And utilizing there a cold building, an old paper warehouse, where we put partly modules in there, and we also built at that time a smaller traditional data center inside the building for our water-cooled systems. So it was easy for us to continue here. There are more buildings, more space available, and there is no problem with the infrastructure to the site. Because the paper factory, it has a power production or power need of about 280 megawatts. So we are small still in comparison with that. And it's local hydroelectric power, sustainable, everything is very good, fits our purposes. So it was easy to put together a proposal for LUMI, and the proposal for LUMI, that is now a consortium of 11 countries together with the EuroHPC joint undertaking. So you see all the countries here on the list, and you have all the Nordics in that consortium, and we have, in addition to a couple of more countries around Europe. So how it works is that each country has put in part of the funding for the machine, and the countries here together is 50% of the funding, and the European Commission is the other 50%. And of course, this system is used for all kinds of different applications. I mean, we talk here about different user needs, and I can assure you from other research, except outside of AI, there are also very different needs and things to satisfy. So this is nothing new to us. But it is also every area have certain specific needs that they want to deal with. I mentioned here a specific application area, and you heard about it. It was mentioned also by Grażyna from the Commission in her talk, the Destination Earth, which is a big endeavor making digital twin of the climate around the Earth climate. And we are large part of this is now done by on LUMI, and we are coordinating some of the projects around this also. So I encourage you to look on the LUMI website, because you find your country-specific access and so on there, and you can get most of the information you need. So from this is how the actual inside the big machine hall, we built the shell around the machine room to make it look like something fancy. It helps to explain when people come there and attract people. People see something nice. And inside that pile of snow, as it from the architect's vision should look like, you see the machine hall, and I will show it on the next picture. But it's really interesting here that we could get so many countries coming together and invest in something that is not placed in your own country, so to say. And I think that has played out very well, and we have succeeded in that sense. So the actual system, it's an HPE Cray EX supercomputer. The performance is 300 petaflops, 380 petaflops. And we come back to how these things are measured. It's not maybe so relevant for the specific AI applications, these measures, but what is important is that it is a big system. And what is a big system in the world? I showed this picture just to get for you to get a feeling for what a big supercomputer is. So this is, every rectangle here represent a HPC system in the world. So these are the top 500 systems. They have been running a specific benchmark, same thing on every system. You measure how fast this goes, and then you get a size of this rectangle proportional to the performance. The green area here is the US, the red is Europe, blue is Asia, and then you have Africa and Oceania on the side there, brown and orange. But what you see here, so this is the measurements now from the spring in June, and the number one here is Frontier, and that is a system in the Department of Energy in Oak Ridge. And that system is more or less the exact same technology, CPUs, GPUs as LUMI, but bigger, as you can see from the size of the scale, of the rectangle. But it also gives you a feeling for how much bigger the biggest systems, the few biggest systems here are compared to the rest. Yeah? And that is a difference. And it changes all the time. I mean, Frontier, they are already planning, as we are doing with LUMI, what will be the next system, what will be the size of that, what the investment, technology, what everything that goes into it. And it was requested here, I heard from some of the AI companies, that it is really important with the size of the system. And I really hope also that the initiative, although the program have changed from the European EuroHPC joint undertaking, directing the money now to these AI factories and maybe chopping up the money into a bit smaller chunks, that we still can get very large systems. Okay, coming back to LUMI. So LUMI as a system is look like this. So it's not only there is one LUMI C here with this more traditional CPU partition, which is quite small in terms of performance. Well, it is big if you compare to normal HPC system maybe, but the major part here is LUMI G, which is the GPU partition then, That's where all the performance comes, basically. But in addition to this, we have parts that are for storage. So there is fast accelerated storage, parallel storage, more disk storage, and then also object store, the 30 petabyte here, where you can put data in the end and share it with your colleagues and the rest of the world and so on. There is also LUMI K, a container partition here, where you could start containers and so on. And in the bottom here, if you remember from the first picture, there was a quantum computer there, and we actually have today a quantum computer connected to LUMI. So from the batch queue, you can submit job to a quantum computer. And we have about 10 projects there that are playing around with this. I will not go into details here, but just to have you to understand how the complexity. So if you start from here in the lower left corner, so that is showing one GPU card in the machine, a GPU server. So it consists of a 64-core CPU, and then it's the GPUs, and there are 4 of these GPU models. Each of them contain 2 GPU dies. So it's 8 of this per compute node. These are connected in 4 ways to 4 different switches that are then, the switches are connected to each other in electrical groups. And there are 24 of these groups with 124 of these nodes in each group also. Okay, so we heard here that you need expertise to fully utilize such a system. And that's my message with this picture, that it requires some understanding for how to utilize this fully, and make your programming and things work properly. And for this also makes the complexity here to have such a full system that works as one system. That also brings these issues that has been raised also with the service, and that when you do service on the system, the whole system is down. Why does it need to be so? It doesn't work so when I use the cloud, etc. And that is simply due to how the system physically is put together and what the operation system can handle. But there is progress on this area, and I save this for the panel, and I hope I get a question then on how these kind of systems evolve. So the interesting thing, I think we have already got an answer to this question, if this can be used by industry. By the way, this background picture here was what PowerPoint suggested when I just put this headline there, can it be used by industry? And I think this shows one of the problems. I don't think it's AI, it's just simple, some indexed pictures that they are putting up about prejudice in this kind of systems, about industry as something big, dirty, and smoky thing. So, how can you use it? We have heard there are 2 ways here for industry. I mean, industry are welcome to make use of the system through the EuroHPC JU calls. They are advertising it here. And will tell further a bit on how we do it in Finland specifically. Because if you see LUMI here, you saw all the countries. Each country have a share of the machine that we are responsible for to allocate users for that. And every country do as they want with this share and how to allocate users for it. And I will tell a bit further here what we do in Finland. So we have specific program for industry users, and all over the machine, also for the Finnish part then, 20% of the capacity is open for industry, and there are these different paths for access. We have had a number of companies, as you already have heard during these days, that have utilized this, and I will not go through the specific. You already heard about these examples from Posiva. Posiva maybe we didn't talk about, but I don't remember now. But ISI and Ramble have explained. So what are the fine details here? That we actually can, and this is the Finnish example now. What we actually do, we have a pay-per-use possibility here. You can actually pay, and you can get you get what you pay for according to a price list, and I will show this price list on the next slide. Another thing that I could recommend, if there is Business Finland here, we have similar organizations in the other Nordic countries. I think it's Business Denmark is there, Vinnova in Sweden. I don't remember Norway now what the similar organization, but the organization that typically support academic industry collaborations. They have actually a grant that industry can be granted money for using LUMI. It is a bit of phony money, but as it goes back to the ministry, basically, when they are using, but it's according to the price list and gives a feeling for the value, and it can be accounted for in the proper way. And that they get together with their R&D calls then, R&D grants that they have. There is also the EuroCC JO calls, and then we have this more public-private partnerships. If there is open research and so on, it is the use for industry is for free. And of course, we know what it costs a core hour, and this is the price list. It is as simple as that. And this is what we use when somebody asks to pay for it, or when we use for this Business Finland grants when we account for the usage. And you see all different flavors of usage here. And what is happening here, you get the LUMI computing project base package that includes some computing time, the support, and just getting access. And that's the base thing we always do for our computing platforms, also on the national way. So also that has been very good for industry customers. We have this LUMI Try and Buy, a free of charge test period. You can come in, get some support, get to understand how it works, what measures you need to take to actually get the machine works for you then. So then after that period, you could decide, will we continue, then make an agreement on how you will continue, or okay, fine, we understand this was interesting, but we will come back later when we know more. So this has generated a number of very good projects and so to say, inspired many companies. It's lowered the barrier to get into such a system. And the team that you should get in touch with, three of them are here. And Juhani there, Don, and the Morten is there. And these are the guys you can talk further to and some of you know them already, that are working specifically with our industry customers. And there is a website and links here, and you have the slides. I hope you share these with the audience, so you can get any further information about this. And that was all from me. Thank you.
Thank you so much, Per.